Hi, thank you for joining the demo session on our e-learning product SkillON365. Today we're going to see what are the features of our product. SkillON365 has got two modules in it. One is the e-learning product and the other one is LMS. So the e-learning completely sits on the LMS, learning management system, which allows our customers to create batches, create classrooms, and modularize the courses. So today, the first I would be covering the e-learning part. So in our e-learning, we have two main technologies that we cover. I mean, courses under two main technologies. One is CNC, and other one is robotics. So under CNC, we have different courses, and under robotics also we have different courses. The main advantage of our skill on 365 is that we keep updating our product at least every quarter. There is an update on the existing course, or there is an updation on new courses. So for instance, right now our pipeline is on automation. So we have got a lot of courses which in shortly going to get uploaded on topics like PLC, SCADA, and fluid mechanics, and even smart factory, industry 4.0, mechatronics, programming, design, and mechatronics. These are some of the pipelines that is coming in, and also there are a lot of feature update getting uploaded on the LMS as well. So with that, today I'm going to demonstrate our skill on 365 on some of the chapters of CNC technology and robotics to know how good the product is. Our e-learning is majorly built with a lot of interactive or high rich digital content like video, animation, audio, text, and so that it makes very interactive for the students to learn. So these are all self based learning courses. So and it has got knowledge checks as well. So under CNC, we would like to cover two topics. One is on basic. So as we mentioned earlier, under each technology, it covers different modules like basic, introduction or basic, and then application, operation, programming, maintenance. So these are some of the modules that it covers. So today we're going to see CNC turning basic, and then milling programming. Uh, in programming, so basically if you take CNC, there are different controllers or the that machine has got, like the some of the OEMs are like Siemens, Fanuc, Mitsubishi. These are the major players worldwide. So we have covered all three major players in our e-learning, and it also have ISO. So if someone would like to know the neutral codes as well, yes, we have the option over here. So today we're going to see in Fanuc milling as part of our demonstration. So to start with, I'm going to start with CNC turning basic. So these are the chapters available under the CNC turning basics. So it includes the introduction to CNC, which talks about what is CNC, how it started, and all those stuff. And then the next chapter covers what are the different components of it, what are the different functions of it, then what are the different tooling systems, and then what are the parameters section, work holding, programming, and operation. So these are the flow of this particular chapter. I'm going to take you through one of this chapter, which is a machine configuration and components, which is very basic and very important uh, chapter for CNC. So under this machine configuration and component, students will be learning things like what are the different parts of the CNC machine, both mechanical and electrical and electronics. And then and once when they go through all these modules, these are the table of content of this chapter, which is on your left pane. So you could see what are the different models, the table of content of this chapter. So it includes different, what is the axis, what is a structure, what is a ball screw, what is a lead screw, what is the CNC controller, what are work holding devices, what is a tooling system basically, and under the CNC controller, what is a drive and a motor, what is a feedback system. And once when they have done all with all these things, then they come to machine specification. So machine specification, in the sense, it's an overall specification of the machine, putting all together as a combined one. What is the actual specification of the machine is what is going to get covered over here. And we have knowledge checks in between, which will allow them to understand what they have learned is and it's correct, and if they want to redo that module or redo that chapter again, so that will allow them to give them a picture on it. So say let's take this particular model, number of axis configuration.
We have three kinds of axes. Let's take a look at them and learn how each of them works. A typical CNC turning machine is configured by two axes, namely X and Z. While the X-axis stands for cross travel of the tool, the Z-axis represents the longitudinal movement.
So, as I mentioned earlier, our e-learning is interactive. So, this includes this graphic representation, which will allow trainee to understand what we are teaching. So, this is one of the module. I would also like to take you through, like, say, for example, ball screws.
Ball screws are classified based on their construction, as we can see here. Precision level screw, termed thus because of its precision level and application, ranges from C0 till C7. Ball circulation type is subclassified into return type, deflector type, and end cap type. Rack and pinion drives are particularly suitable for longer strokes.
So, this just tells you what are the different types of ball screws. So as we move,
A wide range of CNC controlled brands are available in the global market. Click the tabs to view the most popular ones.
this is on Fanuc, Siemens, Mitsubishi, Haas, Heidning, and Fega. So once when they are done, then we can go
All
to the.
CNC turning machines come with a set of specifications which you need to learn about. Click the headings to learn more.
So as we discussed about what are the different components of it, but every component should have some specification. What does it contribute to the machine? So in that case, we have the major categories. So let's say if a capacity of a machine means what are the capacity. So we talk about chuck size, what is the maximum travel in turning diameter and length. So and if you take axis, what is in travel of X and what is in travel of Z. So these are some of the understandings as an overall machine is concerned. Let's see one of the knowledge checks to
Match the
say.
images with their appropriate description. Drag and drop your options against the appropriate images and click Submit.
So this is just to match it with the picture to understand whether to for a trainee to understand whether what they've learned is correct or not. So say, let me do this. If I'm going through this and magnetic chuck, full charge check, and color check. So once when I've done, I click on submit. Okay, so it gives us a result. It tells like maybe you are correct on some, you are wrong on some. So you can correct yourself. This is a correct list. This is the correct answers. So when I see through that, I understand that in these two I've done a mistake. So I put collar check here and I put hydraulic here. So it should be vice versa. So I know I understood. I'll correct myself. This is how a trainee will also learn about. This is on the basics of CNC turning. So we similarly have milling and a lot of other chapters which you can go through. Now let's see on like a Fanuc programming. So on programming part, the actual way of learning a program is that we should start with the blueprint reading, right? So we should give a CAD layout and understand what a CAD layout and how to program, and then write the program for that CAD layout, and then we have to go to the machine and write it and see the output. This is the way traditional CNC programming should be learned. We cover the similar way in our e-learning as well. So for instance, let's say this profile milling. We have a profile milling content under this chapter.
Here is an activity that would help you practice the various program codes you have learned so far. Open your notepad and write the program startup codes, end of the program codes, and part program codes for the diagram shown here on the screen with the help of these data. The cutting tool would be a 6 slot drill cutter. Depth of cut would be 1 The material used would be aluminium. Billet size would be 90 by 90 by 10 and scale would be 1:1. Please note all dimensions are in millimeters, meaning mm. Your program codes, if fed into the CNC machine, should draw a diagram that would be exactly like this one and produce a work that would be similar to the image shown on the right side of the screen here. Ensure you complete this exercise within 15 minutes. Once done, refer the next screen to verify your program codes against the correct ones.
Great. So here it
Here are
explains
the
you.
correct codes for the profile milling diagram. Click the button on the top right corner to view the startup program codes. Click the numbers to view the correct codes that have to be written for the respective spots of the diagram. Click the button on the bottom right corner to view the end of the program codes.
Here you can actually increase, decrease your volume, or you can unmute if you would like to, if you don't want the audio, background audio to run, and then you can use the notes to read. That is also available over here. So coming to this module, so it allows you to, so it gives you the startup of the program and what are the programs at these respective spots, what should be written here, what should be written here, so that it is as per the. So as you know, the billet size, now with respect to the billet size, what program should be written is what it explains here. So that now student knows, okay, this is how, so he practically understands for this particular layout, he how he should write the program. And then we're going to see how we're going to write it in the controller. So basically it is a cycle. So a programming is a cycle which has got 4 modules in it. So starting from understanding the blueprint or the CAD layout, and the second part of the cycle is to know what codes, start codes, end codes, and codes at respective spots. Third is to how to write it in the controller. Fourth one is to see the output, right? That's how the, as I explained earlier, the cycle of programming works. So here we have seen the first two. The third one is how to write it. So when you click on it, it will give you step-by-step activity, how to write the program in the controller. So once when you're done, you can see the output. So finally, he sees the output of whatever he has written. So this would be the actual output of the program. So we have a machining video here, which is displayed. So you could see that it is exactly as the layout is. This is how someone will learn a programming. So we have covered 2 modules in CNC right now. Let's see in robotics. So as we mentioned earlier, our robotics includes introduction in robotics, and then this our e-learning is an application specific one. So we have robotics e-learning module developed for applications like arc welding, spot welding, material handling, and then assembly works. So right now we're going to see introduction in robotics and then arc welding. So here we
Here
go.
is an activity for you.
So here you could see the table of content. We just have minimized it so that we have enough space or a bigger window to see what is happening. So these are the table of content of this chapter. So it starts right from introduction to robotics, history, law, application of it, what are the different joints, what are the different types, and then right away to end effector and kinematics it covers. So I would just like to show one like application of industrial robotics.
Robots have revolutionized the industrial workplace ever since its arrival in the industrial field. According to ABB Robotics Analysis of Statistics from the International Federation of Robotics, most robots do very specific tasks and fall into 10 categories. They are arc welding or robot welding that joins metal surfaces. This improves the safety of workers by avoiding arc burn and inhaling hazardous fumes. Spot welding where two contacting metal surfaces are joined by directing a large current through a spot of an automotive body part. Materials handling, where robots are utilized to move, pack, and select products.
Similarly, it explains all the different applications that are majorly used in the industries. And then we have also created
Press
a.
each tab to view a video on the respective applications.
So when you click on it, it will also have a video representation of what is this application is all about. So that will give you an idea of how the robotics is used, like palletizing, assembly. So just doing in assembly work. So similarly, we have videos for all these applications for students to understand how the robot is used in industries. Let's see one of the knowledge check
Here
as well
is
in
an
this.
activity for you. Drag and drop the tabs to its correct definition.
So I'm just trying to do this and click on submit. So it gives, okay, I had made some mistakes. So it's correcting me saying these are the correct answers. So now I understood, okay, what is what. So whatever we learned there will also, will allow us to understand if we have learned it correct or not. If you want to repeat this module again and come back for the knowledge check is also possible. You can go back, learn and come back. Similarly, we have this knowledge check at frequent intervals to understand we through these topics we have learned it or not. This is on the basic robotics. Let's see about the arc welding. So arc welding is a little more interactive than the rest what we have seen so far. So here it is going to teach us how a arc welding cell is going to be built. So it's a cell, it's an industry cell that is going to be built. So we're going to see how the construction of it. So we have got two modes in it. One is a view mode, which take us through step by step activity on how this is done. And then there is a try mode, which again, whatever we learned, and again with plus some instruction, it will teach us how to do the cell to be built. So now I would like to take an example of her butt joint welding. Let's see how a butt joint welding is done.
Welcome to this demo on creating a robot program using the offline method. For example, 1. Example 1 is a butt joint welding application. A butt joint is a type of weld joint where two pieces of metals are joined at their edges in the same plane. In this part of the demo, you will view the final steps for creating a robot program, such as adding motion instructions in the main routine, adding welding instructions, jogging the robot to create robot targets. Click or press Next to continue.
So as I mentioned earlier, there are two modes, view and try. So let's start with view mode.
It is important to choose a proper tool when you create a program using jogging to the target position. Failing to do so will result in incorrect positioning either when you jog or when you run the program in production. Select Controller. In the Controller Tools group, click the arrow next to Inputs, Outputs. The Virtual Flex Pendant window opens. Now, select Debug. This option gives you access to perform various tasks as listed here. Click PP to main. Now, the program pointer will move to the beginning of the main routine. Select Debug again. Select Menu. Select Jogging. The most commonly used functions are available here.
So this is how the view mode, takes us step by step through various activities. Now I'm going to try it out and see how I'll be able to do it. So here you could see the instruction which says click select controller and input output. I'm going to set the IOs. So in this view mode, it's just taking through the same steps to create the entire cell. And then finally, you could see the cell and programming of the cell and how the welding is done. It will take you through step by step till the end. This is on the robotics application arc welding. So these on today's demo, we saw two technologies, CNC and robotics. And as I mentioned, our e-learning is getting updated often, and we'll be adding a lot of other contents on automation, mechatronics, smart factory, industry 4.0, and so on. So this is about it. Thank you so much.